we're going to talk about the topic du jour, which is context engineering and memory for reliable AI agents. Since I'm introducing myself, I've been in AI for forever, since 2006. I've built two agentic networks. I've worked across very different industries. I went to Stanford. I'm also a Marktechpost editor, and I'm based in Palo Alto, California. All right, so let's set it up. Why are people talking about context engineering today? What did in the last 45 days or 30 days, why did it become so hot as a topic? Well, let's take a step back. First of all, context improves accuracy. Let's not forget that. Why are we even talking about context? It improves accuracy. Whether you fine tune or not, we were just talking about fine tuning. If you add context to a base model, and on the bottom left, it kind of shows based on the size, and on the right, it goes based on if you fine tune. But either way, context helps. It helps with accuracy. If it helps with accuracy, it helps with reliability of agents. And actually, as you increase the number of information, the number of the size of the context that you give to the LLM, the accuracy scales pretty well. If you're giving it a very simple task, which is I give you more and more information in your context, go and find one piece of information. They call this the needle in the haystack test. And as you can see, it starts to really struggle when you're at a 118K, 100,000 K tokens context, which is really, really large. And that's where it starts to struggle. But as we start to say, well, if we want the LLM to do a more complex task, then at 4K size context, that we see diminishing results or no results, right? So as we increase the context to 4K, the accuracy improves and it kind of flattens out or decreases. As we get to a more complicated task, let's say like a RAG retrieval type of scenario. And if we get into even more complex tasks, like reasoning across different ideas across a document, then it really starts to diminishing returns, diminishing accuracy at the 1000K, 1000 size tokens, right? All right. So we're like, oh, great, context helps accuracy, but we can't just stuff the context. Otherwise, it counterproductive, right? And this sometimes people call it context rot, right? As you input the length context, it improves, and then eventually it flattens out or it gets worse, right? And what are the issues with this whole context? If you do a big context, which would be the easy solution, we've talked about information overload. That's why it decreases, but it's also very expensive. And then the latency, the responses of the LLMs just get really slow. And for a lot of agents, that's a big issue, right? And you have lost in the data. All right, well, this is why context engineering came to the rescue. And Andrews Carpenter named it well. Says, what's context engineering? It's the delicate art and science of filling the context window with just the right information for the next step or at the right time, I would say. Okay, so how do we do context engineering? What are some techniques that work today? And I've done a lot of agentic networks. So this is based on my experience and also based on what people have put out. This is the Manus graph that they put out like a few weeks back. I'll pull some data from LangChain, from a bunch of different people, right? So one thing is like, how do you basically leverage cache, right? And how do you manage your cache? And it's a simple way, which is as you have agents, maybe you have multiple agents or multiple agent turn, let's keep the same prompt there. Let's have prompt stability. And if you have prompt stability, you kind of stick with your same cache. If you have your cache, it scales well. That's one way where you kind of optimizing your context. So the context is everything that the LM sees, right? It's the prompt, it's whatever else you add in there and so on. And in there, in the context, there's also the tools. Well, try to have some stability with the tools as well. And that helps. And one of the techniques that Manus came out with was to say, if you, let's say you have two or three tools that you're playing around with your agent, don't activate and activate a tool, just mask the tool that's not for that step. It's a bit of a way to then leverage the cache and not break everything. But I will add that based on the experience and experience of others as well, is you actually don't want to have three tools in there. Try to do small agents, agents that have at most two tools. And so, and the way you do that is you segment whatever the agent's supposed to do, you segment it in smaller tasks. And you say, you agent, your role is this segment. And it could have several turns, but you have a very small task. And if you do that, you don't need that many tools and you can stick with two, and then it makes for efficient context. Okay. Now, agent memory. Why am I talking about agent memory, right? Well, because that comes into play in this whole context topic. And why do we want to have agent memory? Well, we want to, we want to store and recall the past experiences, how you've worked with the agent. And we want to retain context across sessions and maybe even do some analysis and some reasoning across sessions and so on, right? And if you do that, well, you get a magical agent that's really like gives you the magical experiences, like obscene results or analysis or understanding and also knows you and a very customized response. And that's why you need memory, right? And so now you're like, great, how do I manage this memory within my context without having a context stuffing or context rot, right? So Minus says, well, just manage it outside, manage it in files, and basically do sort of a RAG, right? That's what they do. And that would be useful if for your agent, you need very accurate results, very accurate data to the detail level. And because the document or the database that you're going to throw in is going to be very accurate. But if maybe you don't need that level of accuracy. And so this is what LangChain proposes for context, right? And to say, well, wait a minute, maybe I should just think about first, what do I store in memory? So what do I write to memory? And then where do I write it? Like they could be different memories. There's the long-term memory, there's the scratch pad, which is like within the session or even within the agent. Like so there's different layers of memories that you can write to. So first you think about where do I write? And then unlike the previous slide where we're just saying we're going to store everything and then do a RAG and pull it, you could say, well, maybe I can summarize some of this information, so not store everything, right? And of course, LangChain will say on top of that, right, you can isolate the context and figure out which context you bring where and so on and so on, right? So again, where do you should ask yourself, what do I really want to save or write? What do I want to really retrieve? And can I compress it or not? It's better to compress if you can, depending on the level of details that you want to retain. And can I segment the task? If I, again, back to what I just said. Okay, so it's actually interesting. This is an example of what Vertex AI agent engine memory or engine bank, actually, they call memory bank, they called it, just put out. They put out this like maybe 2 weeks ago, where they have an off-the-shelf product where it's a memory product. And what's interesting is the way they do it is they say we're gonna organize the memory by topics across sessions. So we'll group, so when they write based on topics. And do I overwrite my previous memory on a given topic? And that's the decision that that product does. So it's an interesting thing to do. So it gives you another flavor on how to manage memory. Wrapping up, context engineering and memory management, right? So what is context engineering, right? You're dealing with prompts. That could be system prompt or the prompt of the agent inside the agent. You're dealing with what do I do with tools and how many tools do I have in there and what tools do I have? Do I bring in external knowledge? The weather. Do I deal with short-term or long-term memory? And some thoughts are, segment. Less is more. Can you do smaller agents? Can you do simple agents? And then when you think about memory, can you optimize the memory? Can you do by topics or another way to segment the memory, or do you need really a precise database?